Hey folks, welcome back. We are continuing our differentiation rules from last time. So hopefully you remember that. Let's see if we can do a quick problem here. F of x equals ax to the n. What is the derivative of that? Well, I would derive according to the power rule. What's called the power rule. I would multiply the exponent times the coefficient, so that would be n times a. Oh, darn it. F prime of x would equal n times a, x to the, and then we would subtract 1 from the exponent. So there's our power rule. So today, or this section, we're talking about adding and subtracting functions and multiplying by constants. So basically the idea is if you can derive each piece of an addition problem, you can just derive them separately and put a plus in the middle or a subtract. So it's kind of exactly what you would think would happen. This constant is the same sort of thing. If you want to derive with a constant, that constant doesn't play a role. It's just the constant is going to be the constant. So you would derive the piece that you can derive and then multiply by the constant. I'll show you what I mean. What I just said was not a very good explanation. All right, so find the derivative of the following function. So let's find all derivatives on the first couple ones. So let's have you try this one on your own. Let's see. Well, I'll do this one with you as a reminder, and then you can do the next one on your own. So we have f of x here. So if I want to do f prime of x, so the derivative of x cubed is 3x squared. Derivative of 4x is minus 4. The derivative of the constant 5 is 0. Then I can derive again. We call that f double prime. That would be 3 times the 2 is the 6 times x. The derivative of that constant is 0. I can derive again. We call this f triple prime, which would be 6. And then I can derive one more time. We would call this the fourth derivative. Fourth derivative of 6 is 0. Those are all the derivatives of f. We derive until we get a derivative of 0 because every derivative after that would continually be 0. You try the next one. All right, let's see how you did. I don't need to do a rewrite at all, so I can just start deriving. So g prime of x would equal, the 4 comes down in front, gets divided, so I would get negative 2x to the third. Multiply, that would be 6x squared minus 5. I can go again. G double prime of x is equal to negative 6x squared plus 12x. I can go again. Triple prime would be negative 12x plus 12. I can go again to the fourth prime, which would be negative 12, and then I can go again to the fifth prime, which would finally be 0. All right, let's get to one that are a little bit more challenging, a little bit more interesting. What do we do now? So we've got this problem because we've got some stuff added together, but it's all getting divided by this value or this term. So there is something called the quotient rule. We haven't studied it yet. That's the next unit. So if you've taken physics, you maybe have heard something about the quotient rule. We're going to try to avoid the quotient rule and the product rule at all costs. If we can get away from those, life is going to be good. So what I'm going to do is I'm going to try to think about this in any other way besides the quotient rule. So what I can do, if you've got a bunch of stuff divided by one thing, I can break these things up into their own fractions. So this is my rewrite. This is a rewrite here. So this is still y. And I'm going to take it y equals x cubed over. And then I'm going to take this, I'm going to rewrite it into its best format, the format that's most useful to help me clean things up. So that would be 2x to the 1/2 minus, and then I'm going to take this next term and I'm going to put it over. So that's 3x squared over 2x to the 1/2 plus 7x over 2x to the 1/2 plus 5 over 2x to the 1/2. Now, these are not in the right format yet. So this is not simplified. This is not in the A times x to the n format that we need to get it into. So I'm going to do a little bit more work, and I'm going to remember that when I need to clean up fractions, okay, let's stop here and I'll give you a counter example or something that you can relate back to, prior knowledge. Let's say that I had f of x equals 3x to the 7th over 2x to the 4th. How would we clean that up? So we'd have 3 over 2 x to the 3rd. So what did you do to those exponents? Well, I always think about them as canceling. I canceled out 4 of them. But at the end of the day, another way to think about it is to subtract. I did 7 take away 4. That left me with 3 on the top. So we're going to do that with these these exponents. So this is still a rewrite. This is still y equals. I wonder if I've got room to squeeze it in over here. I think I'm going to try for it. Okay, so now I've got 2 over 2. That's 1. That's easy. But then I've got x to the 3rd take away 1/2. So that's 2.5. But you don't want to leave your answer as 2.5. You want to have an exponent that's a single, not a mixed number, but a fraction, even if it's an improper fraction. So 3 take away 1/2 is 2.5. But if I take that and turn it into common denominators, I would make this into 6 over 2 take away 1/2, which would leave me with 5/2. If you're not sure what I'm doing here, pause and write on the side of your paper 3 subtract 1/2. And then clean it up. We'd make that 6 over 2. 6 over 2 take away 1/2 is 5/2. Then I'd move on to the next one. Minus. My coefficients don't reduce this time. So that's 3 over 2. X to the 2nd, take away 1/2. So I would think about this as 4/2. Take away 1 is 3/2. X to the 3/2. Plus, my coefficients don't reduce, so that's 7 over 2. X to the 1 take away 1/2 is 1/2. And then this one's really interesting. I've got my 5 over 2. X to the, I've got no x's take away 1/2. That would be negative 1/2. Or I could think about this as taking the x to the 1/2 from the bottom and bumping it to the top, which would make it a negative. Now look, that is still y. All that work was for y. Now I'm going to derive it, and we're going to go for y prime. So y prime equals, all right, so I'm going to take my exponent times my coefficient, so that's 5 over 2. X to the 5/2 minus 1. So in this case, to get a common denominator, I would think of 1 as 2 over 2. So 5/2 take away 2 over 2 would be 3/2. Minus, I would have 3 over 2. X to the 3/2 take away 2/2, which would be 1/2. Plus, dang it, I messed that up. I forgot to multiply first. So this would be 9/4. 9/4. 9/4 x to the 1/2. Now let's see if I can remember this time. I'm going to do the multiplying first. 7/2 times 1/2 is 7/4. X to the subtract 1. 1/2 subtract 1 is negative 1/2. Now I'm going to multiply first. 5/2 times negative 1/2 is negative 5/4. X to the minus 1/2 is taking away a 1, so it'd be minus 1 minus 2 is minus 3/2. Okay, so from here, there's 2 ways to clean this up. One way is to, well, if this is a free response, you would just stop. But don't stop in a free response in this class, even if this is a free response, because you're never going to get something that easy to do as a free response question. So you're going to always have to clean it up. So the cleanup from here would look something like, there's 2 different ways to clean it up. The first way I'm going to show you is called factor out least powers. No. The first way I show you, I'll just start cleaning it up. So this would be turning it back into their root forms. So that would be 5. Okay, so this is going to be the square root of x cubed. That means that there's an extra x in there. Remember how we did this a while back? I'm going to try to squeeze this somewhere up here. The square root of x cubed. I'm going to break that up into x squared times x. which means one of those, that x squared escapes, excuse me, that x squared escapes and becomes an x, and the other x is left inside. So that would be 5x times root x over 2 minus, okay, this is going to be a 9. That's going to be square root of x over 4. I hope I have enough room for my work over here. This problem better be small. Plus 7 over, okay, now this time that x to the negative 1/2 is going to flip to the bottom. So when I turn it into a root, it's going to be a root on the bottom. Square root of x. Subtract. This is going to also be on the bottom, and it's going to get cleaned up like this one did. So I would have a 5 on the top over 4x times root x. Here's one nice answer. You might see a multiple choice answer that looks like that. But like I said, the other one is, this is your free response answer. This is your FRQ answer. This would be your multiple choice answer. And then there's another one that you might get as a multiple choice answer, and that's the one where we factor out least powers. So let me go up to the top here where we've got some room and kind of do a quick review. Factor out least powers. Now this is a real big move later on when we get into where the function is increasing and decreasing. That's a couple units away still, or a couple sections away. It's the next unit. I think it's unit 3. Let's say that you had something like 6x to the 8th plus 7x to the 5th minus 3x to the 4th plus 5x to the 3rd. All right, if we look at our coefficients, we don't have anything in common, but we do have a number of x's that are in common. So when I factor out, I've got at least 3 x's. The least power is x cubed. So I'm going to factor out an x cubed. Now, what happens to all these exponents? Well, if I take away 3 of them out front, that's only going to leave 5 of them in here. So 6x to the 5th plus 7x to the 2nd minus 3x plus 5. So what did we do to these exponents? Once we figured out who the least power was, what happened to all these other exponents? Well, they got subtracted by whatever that number is. So now let's take this idea. It's the same concept, guys. It's going to be a lot tougher, but it's the same concept at the end of the day. If you believe this and you can do this, you can do least powers. All right, so as I'm looking at this thing, which one of these exponents is the least exponent? The smallest one is x to the negative 3/2. So what I'm going to do here, I'm actually going to change colors so that we can see this a little better. Let's go with green here. This is called factor out least powers. And it's actually kind of cool. So I get y prime equals. All right, we said that x to the negative 3/2 is the smallest thing. So I'm going to factor out x. Actually, you know what? I'm also going to factor out, I should have picked a better example up here. Let's say that all of these things were divisible by something. We would also take out that coefficient. So if this was I really wish I would have changed this. I could make them all 8s, I guess. I'm trying to think of what numbers I could make them into. I'll make that a 6. Ugh, yuck. What could I have also taken out at the same time? If this is a 6, an 8, an 8, and a 6, I could also factor out a 2. So I'm going to take out that 2, x to the 3rd. So I'm going to divide out a 2, so that's going to leave behind a 3x to the 5th. Divide out a 2, that's going to leave behind a 4x to the 2nd. Divide out of 2, that's going to be a negative 4x. Divide out of 2, that's going to be a positive 3. So I wish I would have picked a better example. I didn't, so we're going to have to go back and think about it. So I can take out anything in common. I want to do that here with any fractions. So if you look at this, what also is my least coefficient? My least coefficient is over 4. So what I'm going to do is I'm going to divide out a 1/4 as well. So I'm going to take out, I know this feels overwhelming, but we're going to do a lot of these this year. 1/4 x to the negative 3/2. So I divided out 1/4 and I divided out a negative 3. So let's take this number and divide out a 1/4. That's actually going to turn it into a 10. Because think about it. Think about it this way. If I put it back in there, what's 1/4 times 10? That would be 10/4, which reduces back to be 5/2. Now I'm also subtracting out a negative 3/2. Well, if you're subtracting a negative, you're actually adding. So what's 3/2 plus 3/2 would be 6/2, or x to the third. These next ones are a lot easier because they're all over 4. So when I divide out the 1/4, it leaves behind the negative 9. X to the, okay, this was x to the 1/2. I'm subtracting a negative, so I'm adding 3/2, so that would be 4/2, which would be to the second. 7/4 is divided by the 1/2, so that's 7. Okay, 1/2 minus a negative becomes a positive, so that's negative 1 plus 3 is 2 over 2, which is just x. I took out the 1/4, so that leaves behind a negative 5. I took out negative 3/2. I don't have any left. This then would be another way to factor this answer. I know that's crazy. I know there's a lot of stuff going on there, folks, and I promise we'll do more examples like that. But try to think through how I did that and see if you could maybe do it again on your own if you wanted to cover that up and try again. Okay. So you might say, well, why do I care? Well, later on, you're going to need to know this. So this is my first time introducing this move called factor out least powers. We're going to use it a lot as we go forward. All right, now we have this move here. So in part D, we have this thing. These two are connected by multiply. So you could actually do something called the product rule, which maybe if you've taken your physics, you know that. But we don't have that yet. So we're going to do a rewrite. What does your math voice say to do when you see a bunch of parentheses? Hopefully, it thinks to expand. So y is equal to x times 3x plus 2 times 3x plus 2. I really hope you weren't the kid that tried to write 9x squared plus 4. I wish it were true. It just doesn't work. Okay, so how do you distribute three things? Well, you pick two of them and you times them together. I mean, if you were saying that you wanted to calculate 2 times 3 times 4, you would do 2 times 3, 6, and then times by 4 to get 24. Same thing here. Now, I could also do 3 times 4 is 12, times 2 is, it doesn't matter what order I multiply. I'm going to get the same answer no matter what. And that's the same idea down here. I can distribute whatever I want. So I'm going to distribute the messiest pieces first. So I'm going to do this in my head. What's 3x times 3x? 9x squared. And then the next two is where I'm going to earn my money. 3x times 2 is 6x. 2 times 3x is another 6x, which gives me a total of 12x's. And then 2 times 2 is 4. My next distribution is pretty straightforward. 9x squared, 9x cubed, plus 12x squared, plus 4x. Now I have something that's super easy to derive because it's already in polynomial form. So I don't even need to do a cleanup at the end. We're doing y's here. Y prime would be equal to 27 x to the second plus 24 x plus 4. So like I said, there is a move called the product rule that we're going to talk about down the road, but you don't want to do it. If you could just distribute, that distribution is a lot easier than trying to do the product rule. Okay, so if I step back and look at these again, so you've got this idea of adding and subtracting. Don't change the value of your derivatives. There's no the add subtract rule is very simple. Okay, so a powerful application of the derivative is finding the values of x where a function has a horizontal tangent line. So I want to highlight that right away. Horizontal. What do we know about lines that are horizontal? Horizontal lines have a slope of 0. They're constant. They go like they're horizontal. They have no change up or down from left to right. Then we also have this phrase called a tangent line. To figure out a tangent line, what two things do we need? As always, we need a point, which is x, f of x. Whatever x is, we plug it in to get the y. And then we need the slope, and the slope turns out to be f prime of, I guess I should start writing c here. C, f of c. That means that you actually plug something into it. So, if we're going to find the coordinates and equations of any horizontal tangents to the curve of blah, blah, blah. So what I need to do is I need to figure out where horizontal is where m equals 0. Tangent is where m equals f prime of c. So what would I need to figure out? I would need to figure out where f prime of c, if I take these two together, I need to figure out where f prime of x is equal to 0. Maybe I should use x's, I don't know. I'll go back and forth on that one. Okay, so we're looking at our problem here. I guess I have a y instead of an x, so I'm going to start to figure out what my derivative is. So y prime is equal to, this is a polynomial, which means it's really easy to derive. I got 4x cubed minus 4x. If I want to figure out where my graph is horizontal, I would want to take this and set it equal to 0. Now I'd use my awesome algebra skills to solve this. I see this as a factoring problem. I'm going to do a factor out least powers. Much nicer version of it, but still factor out least powers. So they both have a 4. The least power is an x. That leaves behind x squared minus 1 equals 0. Now I would ZPP these. I would get 4x equals 0. So x equals 0. And I get x squared minus 1 equals 0, which means x equals plus or minus 1. Now, those are good to underline. They're not good to box in because they don't answer any of the question. The question was find the coordinates of the horizontal tangents and the equation of the horizontal tangents. So I got to figure out the coordinates where the horizontal tangent meets this. Well, if I want to figure out some points, how do you find points? I would take my x and I would figure out what the y is. So x is 0. I plug in and I would get 0, 2. I would take my x, which is 1. I would plug it in. 1 take away, so that would be 1. I would take my x, I would plug it in, negative 1. Negative 1 would be 1, negative 1 would be 1, and I would get 1 again. These then are all the points where the tangent line is horizontal. Those 3 points of this curve have a horizontal tangent line. And I'm going to prove it to you. All right, Stucky, pressure's on. I didn't type this in before. We're going to see. So I'm going to go y equals x to the 4th minus 2x squared plus 2. Now, if this is correct, I'm going to change my window right now. Negative 2 to 2. If this is correct, then my y values, or the curve should have horizontal tangent lines at 0, 1, and negative 1. Look at the tangent line. If I drew the tangent line on the very edge of that point right there, that line is perfectly horizontal at negative 1, at x equals negative 1. I go up here to x equals 0. Tangent line is perfectly horizontal. I go over here to x equals 1. Tangent line, perfectly horizontal. What's up, calculus? All right, so now they wanted the equations. Remember, equations for horizontal lines are, if you're horizontal, think about it. Which axis are you guaranteed to hit if you go horizontal? You're guaranteed to hit the y-axis. So you would have equations that are y equals. So that answer would be equations. Now I would actually only have two equations here because two of these points are at the same height. So I'd have an equation of y equals 2, and I have an equation at the height of y equals 1. All right, now we've said this a bunch. It's important to remember that at any point of tangency, a function and its tangent line share two things. So we've said this a lot already, but when you think about a tangent line and when you think about a curve, these two things share a y value and a slope at the same place. So if I have some curve here, this is f, and I draw the tangent line. Why did I draw? I'm so terrible at drawing these curves. I never pick one that's good. Here's the tangent line. The two things that I know are going to be exactly the same. I know that this point is x, f of x, for the curve and for the tangent line. They both share that point, and I know that the slope of the tangent line is equal to f prime at that x value. So those two things are all shared at this place. All right, so find the values of k such that the line, this line, is tangent to the graph of this. Okay, so here we go. What two things have to be true? These two things have to have the same y value, they have to share the same point, and they have to have the same slope. So let's set those things up. Let's first try to figure out the point that they share. How do I want to say that? How about common point? The common point. What point do they have in common? How would I figure out where this point, where this function is at the exact same height as this function? Well, I'd have to do a little bit of work to this, but at the end of the day, what is f of x the same as? The height. What is y the same as? The height. So I'm going to do a little bit of work on this function, and I'm going to convert it into y equals negative 5x minus 9. I'm going to get it into its y equals format. So I now can take those together, and I know that we're going to have a common point when this equals that. So I have a common point when 2x squared plus kx subtract 1 equals negative 5x plus 9. The height of this is f. The height of this is y. If I want them to be at the same height, I'm going to set them equal to each other. Now, for them to be tangent, now I can guarantee I can find lots of places where two lines or two curves hit each other, but they're not necessarily tangent to each other. So the other thing that we have to guarantee is we have to guarantee a common slope. So we have to now figure out the slope of both of these things. The slope of this is very easy to figure out. What's the slope of y? I'm going to call that m sub y. The slope of my y equation is negative 5. We know that because of this thing called y equals mx plus b. Finding the slope of my f curve is a little bit tougher, but not super tough. If I want to figure out the slope of this, the slope of f is equal to f prime of x. So I would derive this thing, which would be 4x plus k. The derivative of the negative 1 goes away. So if I'm going to have a common slope, that means that my slope for my line and the slope for my function have to be the same. So I'm going to take my slope for my line, my tangent line, which is -5. I'm going to set it equal to the slope of my function, which is 4x plus k. And now I've got two equations here, two equations that both are based on k. So I can use them to either substitute or set up a system of equations to try to solve. I think I'm going to go for substitution. So I'm going to try to get k by itself. So I would get k equals, all right, so I would bump this over there. So -4x minus 5. Now I can take this k value and I can take it and plug it in to the k in my other equation. So I'm now going to take this. I wish I would have picked a different color because it looks like that color. Oh, we're stuck with it. Put it in there for k. So my equation becomes 2x squared plus, we figured out that k was -4x minus 5 times by x minus 1 equals -5x minus 9. Now this is something we can do. Little distribution, 2x squared, subtract 4x squared, subtract 5x, subtract 1 equals -5x plus 9. Combine some like terms, I would get -2x squared minus 5x minus 1 equals -5x plus 9. I like the way that's going. I would add them to both sides. I would get those to cancel. I'd move that over here, so I'd get -2x squared, subtract 10 equals 0. Try again. What am I doing wrong? Somehow this negative became a positive. Sorry, that's a negative. That's a negative, which means -2x squared. When I move that over, that becomes a positive 8, which equals 0. Okay, then from here you can either factor, you can solve, however you like to go about it. I'm going to just solve. So I would get -2x squared equals -8. X squared equals 4, which means x equals plus or minus 2. Now, that's helpful. Notice I'm underlining it, but I'm not boxing it in because the question was, find the values of k. So we have this equation here that relates k to whatever x is. So I have two different values for x. That means I'm going to get two different values for k. So k is going to be equal to -4 times 2. Actually, let's just do plus or minus. Plus or minus 2 minus 5. So that means k is equal to plus or minus 8 minus 5. So let's write out our two k's now. K is equal to 8 minus 5 is 3, or -8 minus 5 is -13. And down below, Corpy has shown a picture here of the two curves. Now remember, this k value goes with the parabola that we're going to have here. So as I change this k value, look at, he's got the same curve. This is the line y equals -5x minus 9, and y equals 5x minus 9. But if you put a 3 in there for the k, it's going to look like this. What's happening at -2? We have a tangent line. And then over here, what's happening, if I make that the -13, we have another tangent line. So just a reminder, a point, let me try again. A tangent line and a function share a point and a slope. They both have f of x, and the slope is equal to the derivative. F of x, and the slope is equal to the derivative. All right, let's do some trig here. If you remember from before, we figured out that the derivative of sine was cosine, and the derivative of cosine was negative sine. These are worth memorizing. Now, we do them so much, it's hard to believe that anybody wouldn't just automatically memorize them because we see them so often, but if you haven't memorized these yet, it's time. The derivative of sine is cosine. The derivative of cosine is negative sine. All right, so let's go. Find the derivative of the following functions. Now remember, what we talked about last time, a constant is just a constant. It's not going to matter. So y prime is going to be equal to 2 right off the bat. The derivative of the 2 piece doesn't matter. The 2 is going to be there. Now I'm going to derive sine. All right, now actually let me explain this in a different way. I'll finish this and then we'll talk. Derivative of sine would be cosine. Then derivative of 7 is a constant, so deriving that would be 0. I guess I should put parentheses there because they did. Now, what am I talking about? Why didn't the 2 play a bigger role? Well, let's go back and kind of explain the power rule from a little bit different perspective. So let's say that I had y equals, instead of 2 sine of x, I had 2x cubed plus 7, and I said derive this. Well, you would take the coefficient and multiply, and you'd go from there, right? But really, the way that we should think about it, it's not really worth explaining it this way right off the bat, but it is worth it to think about it now that we've done a lot of power rule. Another way to think about this is to say this is a derivative on its own. So y prime is going to be equal to 2 times, what's the derivative of just x cubed? 3x squared, and then the plus 7 falls away. But my point is this kind of creates a shortcut. It just saves you an extra step. You just right away multiply those two things together. But what's really happening is the 2 remains unchanged because it's a constant. And when you derive the x cubed, it becomes 3x squared. So 2 times 3 makes the 6, and we get 6x squared. That's the same idea here. The 2 remains unchanged because it's a constant, but the derivative of sine is cosine. Hopefully that made sense. If not, let's chat in class so we could talk more about it. All right, so what's the derivative of x plus cosine of x? All right, well, pause. Think about it. What's the derivative of x? F prime of x equals, what's the derivative of x? 1. What's the derivative of cosine? Negative sine. This one is probably one of those identities. One of these years I'll probably look that up, but it's not going to be this year. If f of x equals sine of x, find the following. So the slope of the graph, boom, stop. Whenever you see this stuff, start to write yourself notes. The slope. Now this is the slope at a single point. This is what we call the instantaneous rate of change. This is what we call the derivative. So what we call the instantaneous rate of change. This is what we call the derivative. This is what we call f prime of x. All these mean the same thing. When I see the slope at a point, boom, these are the things that I should start to be thinking of. Instantaneous rate of change, derivative, f prime. Well, let's go ahead and calculate it. So our function is sine of x. I'm going to go ahead and calculate the derivative up here. If f of x equals sine of x, then f prime of x equals negative cosine of x. Try again. I'll remember these someday too. Derivative of sine is cosine, so that's positive. All right, now it's just a matter of a plugging and a chugging. So we would have f prime of x. F prime of x. Well, we're going to figure out, no, I don't want to do f prime of x, do I? I want to do f prime of 0. Equals cosine of who? 0. Draw it out or think through it in your head. Picture the unit circle. Go to 0. Take the cosine of that value, and we'd figure out pretty quickly that f prime of 0 is equal to 1. F prime of 7 pi over 6, same kind of idea, just a little bit more detailed. So I want to do f prime of 7 pi over 6, which equals cosine of 7 pi over 6. Now I got to figure out where 7 pi over 6 is. Actually, pause this. Try to do this on your own. You should be able to do this on your own. Come on. This is pre-calc. This is baby stuff. All right, for those who need the refresher, here you go. I'm being nice today. I'd go to my unit circle. I'd go to 7 pi over 6, which means count around by 30s. So I'm going to count 7 30s. 1, 2, 3, 4, 5, 6, 7. I'm going to take that, I'm going to turn it into a triangle. Now I'm going to take that triangle and I'm going to blow it up. Right angle, reference angle. This is a 30. So who's across from a 30 is a 1/2. Who's adjacent is square root 3 over 2, and I need both of them to be negative. Now, which one of those is cosine? Cosine is the same as x. So we figure out that f prime of 7 pi over 6 is equal to negative square root 3 over 2. All right. All x on the interval from 0 to 2 pi where the graph of f has a horizontal tangent line. All right. You guys have got to get better at recognizing this. Horizontal means slope is 0. Tangent line means slope equals f prime. So if I want to figure out where the horizontal tangent lines are, I have to figure out where the slope equals 0 and where the slope equals f prime. In other words, where does f prime equal 0? So we can do that. That's not too tough. F prime we figured out already was cosine. So f prime of x equals f prime of x. How about that better? Cosine of x, which equals 0, which equals my slope. Now I would start to solve this, and yet again, I'd need to have my unit circle. So as I am on my unit circle, where are the places where cosine is 0? Now what's nice is we only have to go between 0 and 2 pi. We don't have to look forever. So where are the places in our unit circle where cosine is 0? I'll let you finish this. Okay, hopefully you said up here and down there. Those are the two places where cosine is 0. So I would say that my answers are when x equals pi over 2 or 3 pi over 2. Okay, let's stop there for today, and we'll finish up the last 2 pages in another video.